Hello again, class. This is Math 7, Chapter 8.5a. The lesson is entitled Square Roots. We're going to take a little bit of a break from things like area and circumference and talk about some numbers that we use in math. One of those numbers is something we call a perfect square. Now, a lot of times we think perfect square must mean geometry, but it's actually a numerical concept as well. It means that it is a number that is the square of an integer. And I've given you a list of some of the perfect squares here. If we take 0 and square it, remember that means 0 times 0, which will equal 0. 1 squared means 1 times 1, which equals 1. 2 squared means 2 times 2, which equals 4. 3 squared is 3 times 3, which equals 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. Etc., etc. And I've done that all the way up through 15, plus I've given you a couple of them with the, like 20 squared is going to be 20 times 20. Now, if you've got 20 times 20, the 2 times the 2 equals 4. You have 2 zeros, so we have 400. 30 squared is going to mean 30 times 30. So you have 3 times 3, which gives you 9. And then the 2 zeros, which give you the 2 zeros at the end. Kind of a shortcut idea. One of the ways in which we are going to use the idea of perfect squares to do the inverse, which means the opposite operation. The inverse of squaring a number is to take its square root. Quite often it's written with the symbol as indicated here, but on a computer or a calculator, you're not going to see that horizontal crossbar. Some students say, well, it kind of looks like a division bar with an upside down check mark with it. And usually on a calculator or a computer, all you're going to see is kind of that check mark thing. And that is the symbol for square root. If we are going to simplify 49, the square root of 49, we're going to find that the square root of 49 equals 7. And we think backwards. What number times itself gives me 49? Now, if we go back to our perfect square list here, here's our 49. The number is 7 squared. So the square root for 49 is going to be 7. The square root of 196, if we look at our list over here, 196 is going to be 14 squared. So the square root of 196 is going to be 14. The square root of 81, can you figure that one out? What number times itself gives me 81? Yes, 9. In CC and DB, sometimes students get very thrown by this. Really, what the square root of 9 over 16 means is we're going to take the square root of 9 over the square root of 16. The square root of 9 is 3, the square root of 16 is 4. So the square root of 9 over 16 is going to be 3/4. If we're going to take the square root of 9 over 25, we usually skip that second step that I showed you in CC. The square root of 9 is 3. The square root of 25 is 5. One of the most common applications for the idea of square root, there's two of them. One is the Pythagorean theorem, which we are going to get to. The other one is, what if we know the area of the square and we want to figure out the length of the side? One of the ways to do that is to utilize square root. Now, here's the part that you got to kind of wrap your brain around. Area equals side squared. So if we take the square root of the area, we should get s, because the square root of s squared is going to equal s. So let's try this. First of all, we're going to write our formula down. The area of a square is side squared. This time it tells us that the area is the 144. We're going to substitute that for a equals side squared. The square root of 144 is going to equal the square root of s squared. The square root of s squared is s. The square root of 144 is 12. My measurement here is in feet. Now note that I'm finding the length of a side, so therefore it's feet, not feet squared. Remember that square units means area. In C, very similar. If you'd like to hit pause, you may do the problem. I will go through it. I'm going to start with my formula, area equals side squared. They tell me the area this time is 36. So if I take the square root of 36, that should equal the square root of s squared. The square root of s squared is s. The square root of 36 is 6. And my measurement is in meters. Another skill I'm going to utilize is estimating square root. What happens if I don't have a perfect square? For example, here in 2a, they want to know the square root of 40. We can't do this unless we use the square root key on a calculator, and we won't get to that today. What we're going to do, however, is find the perfect squares that are closest to the number. The one that's just lower, the one that's just higher. And this is where your perfect square list may help you. 40 is between 36 and 49. So the square root of 40 has to be between the square root of 36 and the square root of 49, or it has to be between 6 and 7. Let's go on to B. If I look at 96, the perfect square that's just lower than 96 is what number? Check your list. Yes, it's 81. What's the square root, or perfect square rather, that is just higher than 96? Well, that's 100. Therefore, the square root of 96 has to be between the square root of 81 is 9 and the square root of 100 is 10. So my best answer at this point is that the square root of 96 is between 9 and 10. You try C. Okay, I look on my list. The number that is just this perfect square that's smaller than 136 is 121. The one that's larger is 144. So the square root of 136 has to be between the square root of 121 is 11, and the square root of 144 is 12. So my answer should be between 11 and 12. And that concludes Lesson 8.5a on square roots. Please respond with the reply, squares. Catch you later.